Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's class we are going to discuss a numerical on the topic center of gravity of sections with cutout holes. Let's go to the numerical. A semicircle area is removed from a trapezium as shown in figure. Determine the centroid of the remaining area. Here you can see this is a trapezium. From the whole trapezium, a semicircle portion has to be removed. Okay. For this, we are going to calculate the centroid. Actually, guys, this is unsymmetrical section first of all. With respect to the horizontal axis, passes through the center of gravity, or vertical axis passes through the center of gravity. It is not symmetry. Okay, it is not symmetry about any axis. So here we have to calculate x bar and also y bar. So we need the reference lines. Okay, we need the reference lines. For an example, to calculate y bar, we will take the bottommost line as the reference axis. To calculate x bar, we will take the leftmost line as the reference. Okay, so these two lines will act as the reference. Do you understand? So here, this one, that means the bottommost line or otherwise the axis, this one, which passes through the bottommost line, that will act reference axis for y bar. This one, that will act reference axis for x bar. Okay. So here, for our convenient, that means from a trapezium, this semicircle is going to be removed. But for our convenient, the semicircle, we are going to consider as a, sorry, this trapezium, we are going to consider into two segments. Like this, I'm going to split here. So this one will be the rectangle. This one will be the triangle. Okay, so this rectangle and this triangle, we have to add these two for, that means that here we are going to consider area, since rectangle, triangle, semicircle, these are all the plane figures. So these two will be in addition and the portion of semicircle, that will be in subtraction. Okay, so first and second segment we have to add, third segment we have to subtract. Here we have to calculate both x bar and y bar. So I just write the formulas here. X bar, here 1 and 2 will be added, 3 will be subtracted. So a1 x1 plus a2 x2 minus a3 x3, the whole divided by a1 plus a2 minus a3. Same y bar, a1 y1 plus a2 y2 minus a3 y3, the whole divided by a1 plus a2 minus a3. Okay, so this a1, a2, a3, x1, x2, x3, we need to calculate for x bar. y1, y2, y3, along with a1, a2, a3, we need to calculate for y bar. Okay, so first I just start with the segments 1, 2, 3. First one, we know that the rectangle. Okay, the first segment, that is rectangle, and this is the first segment. So we know that for the rectangle, area A1 that equal to B multiplied with H. The H 30 mm, the linear dimension 40 plus 40, that is 80 mm. So it will be horizontal dimension 80 multiplied with the vertical dimension 30. When you multiply these two, we will get 2400 mm square. Then x1, y1. Both we know that linear dimension divided by 2, vertical dimension divided by 2. For a rectangle, the CG, that probably here, that is CG1. That means for x calculation, that will be at a distance 40, 80 by 2. For y calculation, that will be at a distance, if vertical is 30, that will be 30 by 2, that is 15. Okay. So x1, that is 40, can say directly 40 mm, or the linear dimension divided by 2, 80 by 2, that is 40 mm. Then y1, we know that y1, that will be 30 by 2, which is equal to 15 mm. Okay. Then we have to do the calculation for second segment, that is a triangle. Okay. The second segment, that is triangle. So for this A2, we know that area of the triangle of BH. Okay. So here you can see 1 by 2, the base, that is 40 plus 40, that means 80. Here you can see the vertical height of the triangle, that means only this dimension. That will be the height of the triangle. From here to here, the total height or the right side distance, vertical distance of the trapezium is 60. From here to here, 30 means this data, that is also 30 mm. Okay. So the base will be 80 and vertical distance will be 30. So 80 multiplied with 30. Okay. So we will get A2, that equal to 1200 mm square. Okay. Then x2. Okay. We know that the x2 for a triangle, guys, these formulas and all I explained in a separate video, that is an overview of center of gravity. And then the x bar, y bar, these formulas we derived in a separate video, center of gravity by moment method. The video links of both the videos have been attached with the description box of this video. So go to the description box, click the necessary video link, watch the reference video. Okay. That will be useful for better understanding of this numerical. So here for triangle, from the smaller end, if you want to take the distance, that will be 2 by 3 the distance. It may be a linear or vertical. Then from the larger end, it will be 1 by 3 the 1 by 3 multiplied with the distance, or that whatever the side dimension of the side. So here you can see for x, that means if the center of gravity is here, from here to here, we are going to take the distance. Okay. That will be 2 by 3 the distance from smaller end. Do you understand? For x calculation, this one. This is smaller end. This is larger end for x calculation. So from the smaller end, 2 by 3 the distance. Okay. Smaller end, 2 by 3 the distance. So it will be 2 by 3 multiplied with the total linear dimension, that is 80 mm. Okay. So when you simplify, we will get 53.3 mm. Then y2. Here y2 also the same way, but when you consider the vertical axis, this will be the larger end, because you see this side we have 80 in vertical axis, but this side it start with 0 in vertical axis. I'm telling. Do you understand? Here, this one from the larger end, this distance, okay, this distance, that will be 1 by 3 the distance. 1 by 3 multiplied with 30. Do you understand? 1 by 3 multiplied by 30. That is from here. But we know that reference axis for y bar, that is this one. So from here to here, that is 30. 30 plus 1 by 3 multiplied with 30. Do you understand? From here to here, 30. And after that, the triangle is there. That triangle, we know this is larger end in terms of vertical axis. From the larger end, the CG value, that will be 1 by 3, that distance. Here, the distance is 30. For this, guys, this is the distance. The previous calculation we did, that is this distance. Here it is smaller end. From smaller end, that will be 2 by 3 the distance. That's why we had taken previously 2 by 3 into 80. But in vertical, this is the larger end. So 1 by 3 into 30. Okay. This elaborately we discussed in an overview of center of gravity. Watch that video. Okay. So for y2, from here to here 30 plus 1 by 3 distance from the larger end. Okay, so we know that this will be 10. So 30 plus 10, we will get 40 mm. Then the third one, that means the portion which is going to be removed, that is semicircle. Okay, that is the segment 3. So here, A3, we know the value of area of the semicircle. For circle, it is pi r square. Semicircle has half the area of the semicircle, circle. So it will be pi r square divided by 2. And we know that this total distance from here to here, that is 40. This is diameter. When the diameter is 40, then this radius, that will be 20 mm. Okay, radius will be 20 mm. So A3, pi multiplied with 20 square divided by 2. Okay. So when you simplify, we will get A3, 628.3. 628.3 mm square. Then X3. Guys, X3 means the distance of center of gravity of the semicircle from the reference axis for x bar calculation. You know, the symmetry about vertical axis, that means this semicircle alone. So from here, the x bar, from here to here 40, then CG will lie on this vertical axis which passes through center of gravity of semicircle. Okay, CG of the semicircle, that will all lie on this axis. So it will be CG3 here. So that will be at a distance from here to here 40. And here the axis will be 20 because this 40 by 2. Okay, 40 plus 20 or 40 plus 40 by 2 for axis calculation. So this will be 20. So we will get X3, that is 60 mm. Okay. Then Y3. We know here from this axis, here the bottommost line of the semicircle lie with the reference axis for y bar calculation, and this distance, that we know that 4r by 3 pi. Okay, this distance is 4r by 3 pi. So that is 4r by 3 pi. We know the value of radius. 4 multiplied with 20 divided by 3 pi. From this y3, we can calculate, that is 8.5 mm. Now, all the values required for x bar and y bar, we calculated. So now x bar, we substitute, we have already the formula. So substitute the values in that formula. We know A1 2400 2400 multiplied with x1, that is 40 mm, plus A2 1200 multiplied with x2 53.3 mm, minus A3 628.3 multiplied with x3, that is 60 mm. Okay, A1 x1 plus A2 x2 minus A3 x3, that we did here. Then the numerator we did, then denominator. Okay, that means A1 plus A2 plus, sorry, minus A3. So A1 2400 plus A2 1200 minus A3, that is 628.3. When you simplify, we will get the value of x bar, that is 41.1 mm. Okay. Then we are going to calculate y bar. Y bar, the formula we did here, A1 y1 plus A2 y2 minus A3 y3 divided by A1 plus A2 minus A3. Substitute the values. A1 2400 2400 multiplied with y1 15 plus A2 1200 multiplied with y2, that is 40, minus A3, that means 628.3 multiplied with y3, that is 8.5 mm. The whole divided by A1 2400 plus A2 1200 minus A3 628.3. From this, when you simplify, we will get the value of y bar, that is 26.5 mm. Okay, so this is the value of x bar, that is 41.1 mm. This is the value of y bar, that is 26.5 mm. Okay, so we calculated x bar and y bar for the given diagram from the trapezium where the semicircle is going to be removed. Okay, I hope you all understand the numerical, what we discussed in this video. For more videos like this, don't forget to subscribe my YouTube channel, Vishwaguru, a problem solver. Thank you guys. Thanks for watching.